right, guys. So let's start today's session. I hope all of you are here and some may be joining in a bit. Well, first of all, guys, I have been sending you emails and I'll try to send emails. Though, first I'll announce things in this announcement section of the course portal. I mentioned last time that it is important to keep track with the portal and the updates to the portal. I don't know if you folks are getting those updates on your cell phone and on your iPads and so forth. I hope you're getting that. The alternative is, of course, to log in here and see the updates. I might occasionally forget to send emails, but the updates here will be there. As you can see, there are three announcements. First is the survey and week 0 quiz are overdue. When the YouTube videos became available, I posted them. So if you look at this, you have the announcements. The videos are there in the course website. Then we also have other announcements. If you look around, you'll see that the first session today evening, that of course is history now. So there will be announcements on the portal every day. Other than that, there's a social forum. I haven't seen any activity there, guys. You'll get a lot more out of this workshop if you obviously engage with it a bit more. I noticed there are 4 replies to it. The homework start from today, so it would really help you to engage. Now, here's a suggestion. This is collective learning. So as you solve the problem and you do it, share your findings with each other. See what things you tried and not tried. Discuss it on the social forum. And an engaging social forum is very helpful, trust me, in learning the material. People come up with very interesting findings as they go along the workshop. And then part of the social learning you'll notice is that in every section, I try to put a wiki here. So for example, for quizzes and interview questions, you're most welcome to contribute your own questions. You come across an idea, a topic, we didn't ask that question. You can add those questions in the wiki here. Likewise, for the hands-on lab, you can contribute your own suggestions on how to make the lab better. You want to add a few puzzles on the data sets that we are doing, feel free to do that. You can even put tips on how to run this. You know, some of you will get stuck. Maybe I don't use Mac. If you're using Mac, I use Ubuntu. So I may not be able to help you, but some of you, if you find solutions for each other, you can help each other by contributing it to the wiki. So do that. Now today, I have uploaded the week 1 lab and homework. Please start by downloading it onto your machine and unzipping it. I believe on Windows, Nisarg is mentioning that you have to unzip it twice. One unzip leads to a tar file and a second unzip then finally unzips it. On Linux, of course, it is a simple tar xvfz command that will in one shot unzip it. So try that, guys. Huh? First have this ready. Now the way I'm going to do this workshop is, first I'll keep it simple. I'll keep 2 pieces separately. We will first make all of this work on your local machine so that you have a local development environment and a sense of how to do development on your local machines. Once we have done that, after that, we will then move on to the cloud. We'll do it in Colab and we'll do it in Jupyter Notebooks in the cloud. First, we'll do in Jupyter Notebooks on your machine first. So these are 2 separate things. And if time permits, we will not only set up Colab and Jupyter Notebooks in the cloud, we will also bring up this project into the Jupyter Notebook and the Colab. I will leave one of these as a group activity for you. I will not tell how to do it because I hope that will cultivate or foster some amount of collaboration. Maybe I'll explain one, or maybe if we don't get time, I won't explain either, and I'll expect that we all collectively figure it out. Of course, I'll be there to support the findings. So if you, let us start with first downloading it. Let me know if anybody has not yet downloaded this zip file and unzipped it. If you download and unzip it, you should notice that you will end up with a directory called ML400, which is the ID identifier for this workshop. I'll wait a minute for everyone to be able to download this file. Can I please get some confirmations? Anyone confirming that they have successfully downloaded and unzipped it?
Yeah.
All have done that. Wonderful. So our next step would be, and this is something that many of you have already done if you're coming through my previous workshops, but we'll just sort of go through the motions again. What you do is you go to the website anaconda.org. It might be a good opportunity to upgrade because Python 3.8 is out, 3.85. If you're still on an older version of Python, 3.6, 3.7, it is worth upgrading. Some functionalities have really improved gradually, and we will actually be using the features of the latest Python. So you'll see that we write rather idiomatic Python, which means
Asif, do we need to uninstall our older Anaconda, or?
you see, Anaconda is just a directory. I would say that just if you just copy it over elsewhere to something else, and then download Anaconda, the latest Anaconda again, and install it, run through the install process, you'll be fine. So you have a directory called Anaconda 3. It's like, if I remember right, you work on Mac, isn't it?
No, Windows.
You're on Windows. So you must be having a directory called Anaconda 3, Nisarg. Just rename it to something else. You can uninstall it if you wish, then you'll have a clean install. If you have a good internet connection, by all means, just go ahead and do that.
Asif, I think we'll try to do that next class, right? Again, I'm in the older version. I don't have the newer version. Is that okay for the first class?
I think you'll follow through. Occasionally, one or two places, the code may fail. I'll tell you where it will fail if you're on an older version, but you don't have to do it. If you have Anaconda fairly recently, as in 2020, you installed it, you should be fine. For those of you who have not.
Will we lose our original packages which we installed if we reinstall it?
See, generally you can upgrade Anaconda, but in my opinion, upgrades are usually not very clean. Right? You can just do update of Anaconda, and that will take care of things. All your package will stay. My experience has always been that keep replacing it with new installations every once in a while, because it's just a directory. You rename the directory to a backup directory and reinstall it.
Got it.
So guys, here we go. If you go to the anaconda.com website and or org website, I would say .org, you will see a download link for the individual edition. You click on the download link and it will ask you Windows, Mac, and Linux, which of the 3 operating systems you prefer. As you notice, it says that it is Python 3.8. It's a very easy installer. For each of them, it's a graphical installer. For Linux, obviously Linux, the culture is not to use graphic installers too much. It's just a simple script that you can run through. So just run through that script and you'll be done.
Is there a way, Asif, to check what Python version you have on the Anaconda that exists?
Yes, it's very easy. Just say Python, then space, hyphen, hyphen. This is the command you would give. Let me see. Now I'm doing it from a teaching laptop, which is Windows, which I don't use for any other purpose. But let's see if it has one. Yeah, do you notice that? Oh goodness, this is an ancient version of it. But I'm connecting from this to my Linux machine, which has, let's see what the Linux machine has. Let me see if I've enabled access to it.
So Asif, there is 4 and 5 and team edition and individual edition.
No, go with the individual edition.
Okay. So I have a different page. I Googled it and got, okay.
Okay. So usually going through anaconda.org, and I suppose they're trying to also commercialize it. But if you
docs.anaconda.com. I got to docs.
Yeah, it will take you to anaconda.com. They click on the download button. It should take you here, and all you need to do is install it. Guys, I'm going a bit slow because I know in the audience there are a few people who do not know Python. So for that, I have a announcement. This Saturday in the afternoon, we will have a Python session. It will happen right after the quiz. The quiz will happen at noon, Saturday noon. And right after that quiz, the quiz should take about half an hour to review. And then from 12:30 onwards, there will be a Python session for those of you who are interested on Saturday. Once again, if you are interested, please do mention it in the social forum. At this moment, I have received only one person, I believe Premjit, who has said he would be attending. If you are interested in attending, is there anybody else who would like to attend that?
Asif, I could attend.
Yeah, sure. You're welcome. Anybody else?
Yes, me too. This is Gino.
Okay. All right, guys. So remember, 12:30 on Saturday. And 12 o'clock is the quiz. So come at noon. Every Saturday noon, we have a session. Come to that. And after that, we'll do this. After the quiz.
Sorry.
Go ahead, Nisag.
Do I change the name of the directory or do I change the old directory's name?
Usually, I rename the old directory and install a clean one.
Okay.
But Nisag, if you have installed it recently, then it's fine. I believe you were there in the summer class. No? So
I have 3.6.
Oh, that's ancient. You'll get to 3.8.
Okay.
So I'll send you guys a notification or an announcement of this. But Saturday noon, generally Saturday noon, we keep for help sessions. We review the quiz, we do the remediation session. And after that, if time permits, as time permits, those of you who need individual help with your labs, you can get that individual help from me. Now, once you install Anaconda, then what you do at that particular moment is you go into the directory. Actually, I might as well do the same thing as you guys are doing. So guys, how many of you are looking at a screen like this? Like you're able to bring up your Jupyter notebook, you're able to navigate to the directory. Anybody at all?
Asif, we've been posting the chat wall has been there.
No, I didn't hear that.
In the chat room, we've been posting who all are at that place.
Okay. And does it look like most of you are?
Yeah, I'm able to like the
Yes, sir.
All of you are. So I can continue from here. So guys, I'll give you a navigation of the way the projects will work. Every week, I'll give you some starter code. The code would be for our walkthrough. And then in every of the notebooks, you'll find some homework waiting for you. And those homeworks are very easy. They're simple practice and extensions of whatever it is we cover today. Now, today is sort of a basic lab. We are getting started and things like that. Gradually, this workshop will pick up speed. So do brace for it. Keep up with it. If you don't keep up with it, you may start falling behind. So, but today we'll go a bit slow. So once you are here, in Python, you have something called a requirements file. If you click on this requirements file, it will tell you what are all the libraries that we will need. Now, most of these libraries you can install using there's a pip install command. Maybe I should mention it right here itself. You have to give this command pip.
Asif, I'm still not there yet. How do we get? I'm done downloading the Anaconda.
Yeah.
After that, what is the step?
From your menu, bring up Anaconda Navigator. And then start Jupyter Notebook. Now, for those of you who are more familiar with this, of course, you can just give the Jupyter Notebook command. But at this moment, go through this route. If you bring up Anaconda Navigator, you'll be looking at a screen like this. See if you can come to this.
So this is inside the downloaded
Anaconda. No? Did you install that Anaconda that you downloaded?
No, not yet. That's what I'm.
You have to install that.
So it's a .sh. So I just have to run the script file.
That's right. That's it. Rafiq, you're working on a Mac or you're working on a
Ubuntu.
Oh, you are on Ubuntu. So then it will be very easy. Just run that sh file. By the way, of all the operating systems, AI is just easiest on Ubuntu. It is the next easiest are other flavors of Linux. Then comes Mac, and usually Windows support is a little bit flaky, guys. And so you might be in for a lot of pain if you're running with Windows. Some things will work, some things won't. Usually what doesn't work is the fact that your code doesn't use the graphic libraries, the GPUs. To get very good support from GPUs, make sure that you have a machine that has a NVIDIA card and is running Ubuntu. Then you won't have any issues. All right, guys, can we make progress? Can I move forward from here? Rafiq, can I move ahead now?
Yes, you can.
Move ahead. So, so let's look at this. This is your requirements file, as I mentioned. Requirement file is its purpose is at some point give a command like this, pip install. I'll just do even more big. You can take it down, pip install -r requirements.txt. It's from the command line. Huh? Open a command line, and once Python and Conda has been installed, and you give this command, it will install everything in this file. Right? These are the things we will need one way or the other for the first homework. Right? Now, one good news is while you're doing it locally, usually, and I'll show you how to create a Jupyter notebook in Google Cloud, there you can choose to create a compute instance which is fully configured. You don't have to do anything at all. Right? And that's the nice thing about it. But for doing it on your laptop, and it is good to start on your laptop so you have some feel for it, you have to do everything manually. And we are going through the process of doing it manually. Premjit, how far along are you?
I'm good, Asif.
Nice.
I have an Anaconda environment on my Mac already.
Already, excellent. Excellent. So once we are here, now let me give you an understanding of the other things. When you, this particular thing, you can read it. A couple of things that I would suggest is, how do you author Markdown? Whenever you're authoring Markdown, people often say, I have to learn yet another language. You know, Markdown has its own syntax and I have to pick up the syntax. Markdown is a very simple language. It has become a de facto standard amongst programmers. It's sort of like a 5 minutes learning curve. However, there is an excellent and open source environment for it. It is this. And I'll just show what it looks like. Let me see if I have it in this machine. Here, Typora. Do you notice that on my machine now a window has popped up? It's an application called Typora. And then I can go and write anything I want. For example, I'll say we are at, and you can do all of those things that you, like for example, in the beginning, if you don't know, you can do it. And now you can write this, these, some. As you can see, it can do that. And you can create bullets and so on and so forth. And it gives you support for all of those things. You can introduce horizontal lines. So many, many things. In the beginning, if you don't remember the syntax for, it can say item 1, item 2. And then you can save it as a file and it will do that for you. It's a very good environment, in my view, for writing Markdown, besides just writing it in plain text. So that is what I was going to mention about it. It is Typora, Typora. And in this project, you will notice that I have a file here called authoring Markdown. These are all the very basics. Right? One of the things, if you want to know how I use it like this. I use Typora. The theme that I use is Pixel. I turn on the focus mode. It helps you really concentrate on the part that you're writing. Turn on the outline so you see the bigger picture. And there is also a very good Markdown support in Sublime Text. Those of you who are using Sublime Text, it's also there in Atom editor. And I'm sure it's there in just about every other editor. Eclipse has a support for it and so forth. I'm sure Visual Studio Code would have a support for it, but I haven't checked. So that's something worth looking at. The next is the hardware considerations we covered last time. I wouldn't go into that now. Now, let me explain the directory structure here, guys. This text directory contains a few sample text files. These are sort of the famous classics, like, for example, the United States Declaration of Independence, the Lincoln Gettysburg Address, then Shakespeare's sonnets, Charles Dickens' Tale of Two Cities, India, when it became free, the Tryst with Destiny speech. So if you can click on it, you will come across the text for that. We are going to use this text for today's lab at some point as we make progress with the NLP. We'll get introduced to a topic called natural language processing. Today, when we do natural language processing, we'll do very lightweight AI. It will just be getting introduced to the topic, but it's a good day to start. Other than that, there is a directory for handling data, but this is empty, ignore it. There are two important directories. One is notebooks. Notebooks is for Jupyter notebooks. And as we learn is our library. In other words, what I have done is I have taken some of the complexity out and put it in the library here. You can go and read this, not all of it, but read whatever you can. I'll tell you what is worth reading as part of the homework. And when you do that, let's say that you go into, let's go into what? A transfer. Right? And if you just click on that, you will come across source code. I would say that when you come across source code like this, in the beginning, it may look very intimidating. Read it, glance at it. After a little while, it will become familiar. I do not expect you to make much head and tail out of it yet. Right? At this moment, focus only on the notebooks. Right? But these are the codes that I have put there. This Python code to make your life easier, to make it easy for you to navigate through this workshop. So we will focus on the notebooks first. Here are the notebooks. Now, when we run our notebook, one fact that will be there is that we need to include our svlearn in the path before we run it. And so you'll see everywhere in the beginning, I'll be putting the svlearn thing there. Now, if you're running in a Jupyter environment or a Colab environment where you may not always have access to the shell, then you can run this script. What this script will do is just a one-liner. The purpose of this script is to make sure that in your environment, all the necessary libraries are installed. All it does is it installs the requirements. So when you run it, what will happen is, and I'll show you what happens, you go into a notebook. So guys, this is saying navigating to a notebook, opening a notebook, many words for it. And a notebook is made up of two kinds of cells. You notice here, two fundamental things. These are the fundamental units. These units are called cells of a notebook. A notebook is essentially one page. It's a file that ends with the extension IPy notebook, IPYNB. Any file that ends with this extension is a Jupyter notebook. Now, Jupyter notebook is comprised of many cells. In this particular case, we have 3 cells. One cell of text. The text is always in Markdown language, which is why I emphasize learning Markdown. Do you notice that this is a hash mark means it's a heading? After that, it's just plain text. It will respect your line breaks as paragraph breaks, new paragraphs, and so forth. So this is text cell. This is code cell. And this is, of course, an empty cell. We can get rid of it. So 2 cells are there, code and this. Now, when you have a code cell, Jupyter Notebook allows you to do some sort of magic. Whenever you see this exclamation mark, think of it as one of the magic commands. It just, exclamation makes you escape and give a command in the underlying machine's shell. So if you're sitting on Ubuntu, you can give this command directly from the command line. But if you want to give the same command from inside a Jupyter notebook, what you do is you prefix it with an exclamation mark, and then you run this command. Let us see what happens. So what happens when we run this? It becomes nice looking text here. And what happens when we run this cell? Look at this. This cell ran. And what it is saying that on this machine, by the way, this machine is not the laptop. I'm connecting it to this machine called Meta, which is my Ubuntu server. And there, all of these things are installed, which is of course true because I work on that machine. Things are installed there. Right? So I invite you to run this command in your notebook. If you have successfully opened it in Jupyter, please go and run this notebook. Now you can run this notebook in many ways, guys, and this is becoming familiar with Jupyter Notebook. You will see that there's a kernel here. Kernel is the back-end engine that runs your notebook. It's sort of like a client-server model. Your Jupyter Notebook is ultimately just a HTML client. It's a thin client. But it communicates with the backend, in the backend, with a server, Jupyter server. And each notebook is considered a kernel. At the backend, the thing that manages this notebook is the kernel. So you can do all sorts of things. You can restart, clear output. So for example, if I restart and clear output, let's see what happens. You saw that output disappear. You can say run all, right? You can just say restart and run all, and so on and so forth. So you can do all sorts of things, reconnect to the notebook if your connection gets disconnected. This is particularly true if your kernel is elsewhere. Like for example, in my case, my machine is on Windows. I'm doing this thing on Windows, but the server is obviously on a Unix machine, an Ubuntu machine. So you can do that. So anyone of you could confirm that they successfully ran this file?
I did.
Wonderful. It worked, right? I hope there were no surprises there.
Yeah, me too. It worked.
Excellent. Excellent. So now
it's like it was already installed. So.
Yes, wonderful. So guys, now I'll start with something, with the main thing. See, Jupyter Notebook is sort of like an IDE. It's a development environment. If you go and read my notes, which I hope you did about the hardware and the installation, I suggest that you install the Jupyter extensions also. When you install the Jupyter extensions on your machine, a lot of facilities, a lot of features become available, which normally are not available, like the ability to generate table of contents. Do you see this here? You can see the table of contents. So when your notebook becomes very long, it's very hard to keep scrolling up and down. You can just quickly go to the table of contents and see it. You also get a lot of extras when you install that snippets. So you have snippets, you have examples where I have not fully installed it here on this machine. You can do highlight text, you can do all sorts of things. You can prettify your code, you can make sure that it looks nice. And there are many, many things you get along with just getting this. You also get the ability to introduce LaTeX, right? So suppose I'm here. Let's try this as an example to illustrate what I mean. Suppose you want to write a mathematical expression, and let us say that you don't know how to do that. Right? A lot of people don't know. So you can say, well, how would I, for example, write an equation? Here we go. Do you notice that it wrote the LaTeX syntax for equation? Right? Equation, let us say this is equation quadratic. I'll give it a name, quadratic equation, and we can say y is equal to, what is it, 3x square plus 2x plus 1, let us say. Let's see what happens. Do you notice that you got beautifully mathematically formatted equation here? So these are facilities you get through that. Likewise, you can have these widgets. You can embed some widgets into the code, into this thing. And there are many ways of doing widgets into this. I won't mention it, but I'll talk about widgets. What are widgets? There's a separate notebook that illustrates that point. So this is becoming familiar with your Jupyter Notebook. It's something that takes some time, guys. Huh? But nothing is hard. And the way to do that is to start with the very basics. And every once in a while, you'll notice something useful. Somewhere, you'll come across something that you'll start finding useful. Like, for example, for this, suppose you want to write some Python code. You'll notice that there are a lot of examples already here. Right? So, for example, how do you go and do list comprehension? which is something very Python specific. So people who come from C, C++, Java background, they have no idea what a list comprehension is. So it is this, and we'll talk about it in the Python class. It just says that from -10 to 10, right, for all the numbers, so that would be 21 numbers, you produce the square of them. Let's see what happens. Sure enough, you see the square of those numbers. Right. And this is again Python specific syntax. When you're learning Python, you may not remember a lot of these things, but you can quickly look up the snippets and use it to do. Likewise, you can use this markdown to insert, things like that, insert local video, insert remote video, and so forth. So for example, here, right here, suppose you want to do, and again, I'm just randomly moving around. Let's say that you want to insert a remote image. All you have to do is, well, this is a bad place after the equation, let's say. Here we go. Then, obviously, this image doesn't quite exist. But if you go and bring a real image, let us go and get a real image for that. And there are many sites for free images. We will use images a lot in this workshop for our deep learning. So get familiar with this. Unsplash is a great site to get images. So let's say zebra. This looks like a perfectly good zebra. Let's copy the image address. And once we have copied the image address, let's add it to, where were we? We don't need this, we don't need this, we don't need this, we don't need this. We were somewhere here, instantiating. Yes, we were here. So we can go here and we can put this URL. Once again, if you're familiar with HTML syntax and Markdown, etc., so sometimes you may say, well, I don't need to be spoon-fed. I can do these things on my own. But when you are entering this field, a lot of people who come into this field, they come from a deep, back-end database background, data warehousing, or they come from systems programming or for embedded systems and so on and so forth. So they may not be familiar with Markdown and HTML so much. So you notice that with one click of a snippet, we are able to bring a zebra into our story. Right? So these are the snippets aspect of it. You can introduce LaTeX, you can introduce even this. As you write code, for example, you want to plot something and you forget how to do a plot. You can go to the basic plots. For example, you feel like making a 3D plot and you have forgotten the syntax for it. Let's go and do that. Here we go. Now, if you look at this data, it's a very simple data. It just takes X and Y values and it creates a, by now, if you look at this, you would realize that it is creating something like a, well, you'll see what it creates. It's very simple. And it is creating sine X square plus Y square. It looks up a particular shape with ups and downs. This. And you can run this. Yeah. Oops, NP. I forgot to import NP. Import. Let's try a lot now. Plot. It needs matplotlib. Plot. As you can see, not all this plot. Sorry, import as PLT. Hopefully this should solve our life now. There we go. So do you notice that, guys? You got it. But the thing is that by having this snippet, you can quickly see or get an example, and then you can iterate over it. Maybe your data range is different, your function is different, but here is a way to quickly see it. Use these snippets. Today, I've given you a homework which will require you to use the, actually, is it today or next time? It will require you to do 3D data visualization. So that is about notebooks. Now, in notebooks, there is one feature that is quite useful. If you want to make the notebooks interactive, in which you take values from the user, you can actually do that. All right, guys, so here we go. What can this do? This helps you. You can install this, and it will, in my case, of course, everything is pre-installed. But I wanted to show you what it does. You import it, and suppose you want to have a function, f, function x, and you want to create a slider. Do you notice that you have a slider now? You can use the slider to capture the value x, right, what the user enters. Likewise, in your notebook, you can have Boolean, true, false. You can have a text. The user can enter a text. You can play, and these are just examples. You can play from here. Do you notice this? It's a play button. You can play from certain value. And this is very good when you want to run a few epochs, or you can start with certain values during your deep learning sessions. These things I'm introducing you to, obviously you may wonder why, but become familiar with it. You'll need it in due course of time. Likewise, you have a date picker. You can pick dates. These are standard UI components. People who know UI in every language, they look forward to these components in HTML, in JavaScript / jQuery / I don't know, Angular, etc. Then in Qt and whatnot. This is something actually you might like, and most of you, especially those of you who have been doing ML 100, 200, you know that we paid some attention to formatting our data frames, data tables. This is something different. It gives you interactivity in your data frame. So let me show you why it is. And it is something that I like very much, actually. This is called the QGrid. Surprisingly, most people are not aware of it. So once you do this, let's see what happens. Here is some data, some random data. This is the iris data set. What am I doing? Can one of you tell? And obviously, those of you guys who are new to Python at this moment, I apologize, but I'll explain what it does. This line loads a data set called iris. Iris is sort of like the hello world of data science. One biologist, one fine day, walked into a meadow where iris flowers were growing. And he picked up, I believe, 3 species of iris, and he picked 50 samples of each. And he brought those 50 samples, so total 150 samples of iris flowers, and he measured carefully the length, the width, the petal length, petal width, sepal length, and sepal width of each of those iris flowers, and tabulated them by the species they belong to. So that data set is the iris data set. It has 5 columns: petal length, petal width, sepal length, sepal width, and then, of course, the species of the iris. And those of you who are familiar with iris would know iris is one of the most beautiful flowers, and it comes in a tremendous variety of shapes and sizes. Different species of iris look quite different from each other. They all look beautiful, but they all can look quite different from each other. So this data set is interesting because in machine learning, we try to build models to see if the machine can learn how to distinguish between one species and another. Quite often you'll see very scholarly research papers, and they would explain the algorithm and they'll show how well it works on the iris data set. So this is the iris data set. We load it into something called a data frame. A data frame is nothing but like a spreadsheet representation of your data. And then you take the data, and then you give us basic statistical summary of it. Describe will give you descriptive statistics. If you remember the descriptive statistics from your school days, it's your mean, median, standard deviation, and the quantiles, min, max, and 25th, 50th quantile, and so forth. These are the headings. And here is the table. If you look at the data set itself, just do data frame. This again is very familiar. It has, again, as I said, 150 rows and 3 species. Target value has value 0, 1, 2. But now see what happens if I try to run it through this. Oh, why did my grid not show up? It should have showed up. Okay, something is off. I'll fix this code. It should have showed up. Maybe because of the remote or something. But what will show up here is a beautiful, the same data frame here, but with the ability to play around with it filter it and do things the way you see in rich HTML or jQuery or Angular-based components. And I suspect it is backed by something like that. It comes out very interactive. So these are the interactive elements of that you can embed in your Jupyter notebooks. I'm emphasizing Jupyter notebooks quite a bit. And by the way, these are taken from a particular article here. You can go here. Maybe we can see it working there. 1 second. Jupyter widgets, date picker, color picker tabs. Yes, do you notice that you can do pretty fancy stuff, interactive stuff with your pandas data frame the moment you wrap it up with this widget? Are you guys able to see this visualization here? I'm not getting any.
Yeah.
You are. But
So, Asif, what is this article? Can you put that link in the chat?
Oh, yes, it is very much there in your code itself, right here at the very top. Read this article.
Thank you.
In the notebook itself. So whenever I take, usually you'll see that the notebooks come with a lot of references to articles to read. So do read that and you'll have fun with that. Okay. So that is about widgets. Now let's get more real. We will use a framework in deep neural networks called Pytorch. There are at this moment many competing frameworks. There's Theano, Caffe, TensorFlow, and then there is Pytorch. Of all of these, at this moment, the mind share is taken by TensorFlow and Pytorch. The way it started out, first there was TensorFlow 1. It was very low level. It was, you had to describe a whole graph and how the execution graph would be found pushed onto the GPU, the graphic unit, the graphic and compute engine. And a lot of people found it very hard to deal with and debug. It didn't look like normal code. It looked like very clumsy. So people in the open source world, they created a project called Keras. Keras really put a layer of simplicity and rationality on top of TensorFlow and became a runaway success. Everybody wanted to use Keras. And Keras was also a layer, I believe, on Caffe and other things, but primarily on TensorFlow. Then Google ended up taking their main Keras developers and making Keras the front end to their TensorFlow. So the TensorFlow 2.0 has Keras as its front end. Also, because TensorFlow 1.0 was getting problematic, then Facebook came out with Pytorch. The Pytorch is a very, very intuitive data science or deep learning library. People who are familiar with NumPy library to deal with arrays and matrices, there is no learning curve at all. If you have worked with NumPy and scikit-learn, and those of you who have been with me doing ML 100, 200, you all have. You realize all of a sudden that there is very little new to learn. You already hit the ground running. There is something to learn, but from day one, you can become productive. So that is Pytorch. Pytorch has been gaining a lot of momentum. At this moment, the way it stands is that the community used to be predominantly TensorFlow, but now more and more it became Pytorch. Pytorch has essentially taken over. At this moment, it is at 50-50. But the momentum is with Pytorch in the research community, partly because when you write code in Pytorch, you'll realize that it's very intuitive. With the TensorFlow, the world is like this. If you can write that code in Keras, it will be even simpler than Pytorch. It's very easy. But the moment you want to do anything beyond just the copy paste or the basic, the cookie cutter stuff, then Keras doesn't take you very far. You have to go down to the underlying TensorFlow libraries, layers, and those layers are frankly a pain in the neck. So I used to be obviously predominantly TensorFlow, but in recent years, like everyone else who likes to write their own neural architectures or play with things, I have moved to Pytorch. As we go through this workshop, actually the previous incarnation of this workshop, or the precursor to this workshop was in TensorFlow. This one will be in Pytorch. So I would like to introduce you to Pytorch as a library. And I hope you'll agree with me that if you know the standard numerical library, NumPy, it will be very easy. Now, those of you who don't despair. Remember, we have the starter sessions on Saturday. You'll become experts at it in 2 weeks. Like 2 sessions, 2 Saturdays, and you'll be very smooth with it. It is easier than it looks. But going forward, let me show you what I mean by that. Now, most of you are familiar, except for the import torch, I hope this import is almost like a necessary song you all sing in the beginning of each of your notebooks, Jupyter notebooks, isn't it? These lines that I've highlighted, I trust you guys are all very, very familiar with. Would anybody like to agree with that?
Yeah.
NumPy, matplotlib. So what does it do? This is the numerical library NumPy. Matplotlib is the plotting library, and really well done. I would see one of the things that you realize in data science, the data visualization libraries are just absolutely wonderful. Absolutely wonderful. You can do a lot of visualizations with just a couple of lines of code. And it isn't that the libraries are there. You have a problem choosing between many excellent libraries. Many excellent libraries. It's sort of, there is not enough time to learn all these wonderful visualization libraries. People have really gone out and put a lot of effort. In the world of R, of course, you know, ggplot is very respectable, is based on the grammar of graphics. ggplot and D3.js in the world of JavaScript are both influenced by a philosophy called the grammar of graphics, very influential philosophy. That philosophy has also influenced Python world in the Vega and the Vega Lite framework, based on which we'll use Altair. But the old visualization framework in Python is matplotlib. It is the simplest, it's the one most often used till people become more conversant with powerful libraries. So take this as a baseline. Just as in R language, if you just give the plot command, it comes built into R. The plots don't look very pretty, they don't look amazing, but they get the job done. Right? In the same way, matplotlib comes under that category. Now, matplotlib has been putting in a lot of effort these days to be compatible with the richer libraries. So one of the things that people haven't yet realized, that actually you can write matplotlib code, but you can tie in one of these richer libraries like Bouquet and so forth, or Seaborn, and your same code will get rendered more powerfully using this more powerful visualization backends. It's just a fact I'm dropping now. We will see illustrations of it as we make progress in this course. So let's try to understand this course, what it is. This is a magic. So you see this percentage something. This is a magic command. It basically says that when I plot something, I shouldn't have to say a plot.show. Just assume that any plotting, the moment a plot comes into existence, you render it inline in the page itself, right? And not in a window, not somewhere else. Literally in the Jupyter notebook itself, you render it. So that explains these 3 lines. The one new line that you encounter is the very first line, import torch. That imports the Pytorch library. Are you together?
Asif, one quick question.
Mm-hmm.
Somehow the import torch is just giving an error for me. Maybe I missed something in running? Somehow the requirements.txt also didn't run through fully for me.
That is the reason. That's the reason, Ramki, why you're getting that. So what we will do, that needs to succeed, right? Because that will install the libraries. And so come to the Saturday session. We'll sit on one-on-one and fix your environment.
Okay, perfect. Thank you.
Yes, excellent. So, all right, guys. So I'll just give a few illustrations. Here is a standard NumPy code. If you look at this code, I hope you all will agree that looks very easy. You create a linear space of numbers from -2pi to pi, and you create how many of those numbers? You create 100 of those numbers. This is the beginning, this is the end, and how many numbers you want. So it will create an array of 100 numbers going from -2pi to pi. Then I'm writing y as a function of x. I deliberately wanted to take some complex function this function is a sine wave in x, but with an exponential decay built in. You notice I put an exponential decay here. Right? So if I have to write, so let us write the mathematical formula for that. It is equation and equation. So now, can somebody tell me how I would write this? I would just copy this and remove the NP here. This is late language now. Let's try that now. And all you're doing is, you notice that people who write mathematics are used to writing in this funny syntax. And let's see what happens. Oh, no, I made a mistake. Solute. Right. This is it. Or if you want to make it look more traditional, you can say like this. There we go. Do you see this equation, guys? What I've done is I've taken a simple sine wave and I put in a decay so that it decays down. Why did I do it? No particular rhyme or reason. I can change this equation. You can make it whatever. I just wanted to take some equation of x. So I took this. Now let's run this. If I plot this, right? Oh, NP is not defined. Let's run this. So this equation comes. And now let us get introduced to Pytorch. We will compare this. I will just decrease the fonts a little bit. Look at this, guys. This equation, this is the standard code for writing it in NumPy that you're familiar with, and see how we write it in Pytorch. Can you tell what the difference is? All we did is we replaced the NumPy NP with Torch. Can you see that, guys? And amongst the more marvelous things is the fact that matplotlib works just fine with Torch objects. So Torch objects are called tensors. Tensors is a mathematical term. They are a generalization of matrix to higher dimensions. We'll talk about tensors. The concept of tensors we'll cover next time. But just think of like a array is one-dimensional, a matrix is two-dimensional. Now, how would you generalize a matrix to 3 dimensions? Add a z-axis to it for numbers. When you were to do that, it becomes a tensor. And tensors are of arbitrarily high dimensions. They can be a point, a number is a tensor, and all the way to any number of dimensions you can have. So it's a generalization. Right? Now, in NumPy also, you could do that sort of thing. So one question that comes is, when NumPy exists, why would you create a library that pretty much mimics its API? Would somebody like to take a stab? Why in the world would you create a library like this?
Extra features.
And what are those extra features? What are the big things that NumPy doesn't have?
Some GPU.
GPU acceleration.
GPU acceleration is an important feature, but then, you know, we could have put in effort to retrofit NumPy with GPU acceleration. By the way, the effort is happening. There is an effort to make that happen.
It doesn't support tensor.
Yes, sort of, we can retrofit NumPy somehow to do that. See, that you could extend it, right? Why create one more open source library? Actually, the reason is very interesting. It has to do with the fact that we want to express, or we want one thing in deep neural networks, or two things, just two things we need to do deep neural networks. And it's a relief, actually, when you think about it, that all these complicated textbooks and research papers, they can all be boiled down to two essential operations. One is matrix addition and multiplication, which is very easy. You know how to multiply an array with another array, right? In one way or the other, we can all do that. So matrix multiplication. And the other is make differentiation of matrices, differentiation of functions. So what happens is when you describe y in terms of x, it would be nice if automatically the framework not only understood the moment you told y as a function of x, it also explained to you immediately and said, all right, now I know what dy dx also is. Wouldn't that be wonderful? So you don't have to explicitly compute it. So that is called autograd. The generalization of differentiation is gradient. So people call these libraries having the ability of automatic gradient, or put it differently or simply, automatic differentiation. That is a huge plus with Torch, PyTorch. Right? And when I use the word torch, it should mean PyTorch. The other aspect, of course, is Torch is optimized to run on GPUs. It will run on CPU. If you don't have a good GPU, it will run just fine on your CPU. It will just take probably 10 times as long, right? Or maybe 100 times as long sometimes. But it does run. So when you do the same computation with NumPy, what happens is the computation doesn't benefit from the GPUs because NumPy only runs in the CPU. The CPUs are general purpose engines. They are not really optimized for large matrix multiplications. And by large, I really mean large. I believe in the session before on Tuesday, I mentioned that some of the latest transformers and these neural network models and CNNs like Inception, we are talking about parameter space that is in hundreds of millions or even a billion. Ridiculously large matrices we are multiplying. So to be able to multiply those giant matrices, you need dedicated video cards with humongous amounts of memory. So some of you, I don't know if you have kept track with it, NVIDIA has just announced the RTX 3090. Right? I'm, for example, waiting for it to hit the market. The 3090 has, I believe, 24 GB of video sitting next to the GPU, the graphic processing unit, very close to the GPU, so that it has a direct path to the GPU. It doesn't have to go to the computer's memory. By the time you go to the computer's memory, it's already too late and too slow. So that's the benefit of using TensorFlow. That's what, I mean, either TensorFlow or PyTorch. These are libraries that are created with GPU in mind. PyTorch's ability to do automatic differentiation or automatic gradients is huge. Much of neural networks that we are going to learn, they have two steps. The forward step is just matrix multiplication, and so-called backward step, which is a propagation or a differentiation, a wave of derivatives or gradients propagating back towards the input zone, right? From input to output. If you think of it as a long pipeline, in the forward direction of the pipeline, you have multiplications going forward. In the backward directions, you have the gradients flowing back. And we will see that. So anyway, suffice it to say that there's a good reason to have a separate library that looks very close to NumPy. Why is it deliberately made to look like NumPy? Because everybody in this world is more or less familiar with NumPy. By the way, even if you come with R background, you would say, well, bad luck for me. I come from R, I don't know NumPy. But actually you do, because below both R's library and NumPy is underlying it is almost always the same Fortran library, Fortran and C libraries. Those libraries are BLAS, basic linear algebra system, and so forth. So those libraries have not changed, and nobody is foolish enough to write everything from scratch. They just put layers on top of it. NumPy is a layer on top of it. And so if you are familiar with R, it becomes a no-brainer to quickly become familiar with NumPy, and therefore familiar with Torch. It's just that there's syntactic difference, language differences. Once you get used to the language difference, it becomes easy. Right? All right, guys, we're coming up on a break in 5 minutes, so I would like to finish this part. Likewise, a bell curve. You may say, well, you know what, that was perhaps too easy an example. It isn't easy. I wouldn't exactly call this function easy, but let's try something else. What about you take a bell curve? Bell curves are everywhere in machine learning. Here is the code for a bell curve. Right. There's a denominator. Maybe I should write the equation for the bell curve also. Might as well. Those of you who may, I should have done that perhaps. Would anybody like to remind me the equation of a bell curve? Equation. Y
e to the power of x squared by 2.
This over this over 1, yeah, okay, 2 pi, 2 pi, and SQRT, and SQRT square root. And then this would be, of course, the exponentiation of it, e to the power. Let me just use exp, exponentiation of what? Minus. Well, obviously I'm giving the simplest version of a bell curve here. Minus frac inside it. X power 2 over 2. Let's try a luck and see what happens. Oh, this would quite, it is correct, but it looks sort of ugly. So I will make it 1. Let's look at this. All right, guys, here I've taken sigma is equal to 0. The mean is 0. I mean, the standard deviation is 1. And what is the mean here? Mu? 0. Right? Centered at 0 and 1 standard deviation wide, a standardized bell curve. So, in this equation, I forgot to take the square root, but all right. NP, you can say NP SQRT further.
Standard deviation 1, no? Mean 0 now.
Mean 0 and standard deviation 1. Yeah, that is right. So guys, in this, I've forgotten to take the square root. I'll leave it there because we're coming up on the break, and I'll leave this as an exercise for you to fix in the break. So this is the NumPy code. And what is the Pytorch code? Do you notice the Pytorch code? Does it look exactly the same, guys?
Yeah.
That is it, right? So these things work very similarly, right? But then not always, it's not always true. So for example, the function syncx, it's a famous function that you use in signal processing, sin x over x. So if you write the NumPy version of it, you will realize that there is no equivalent of it in TensorFlow, but then that's no harm. All you have to do is take a tensor, convert it back to NumPy. So how do you convert a tensor back to NumPy? You just call the .numpy method to it. Right? And it will make it into a NumPy, and then you compute the value, and then you convert it back to a tensor. So if you look at this line and try to sort of unpack it, what we did, we created a XX tensor. In this inner part, let's look at the inner part of it, this one. We have converted it to NumPy. Then what did we do? We used the NumPy library to find the sync of it, sin x over x of it, and then we have a NumPy. And then all we need to do is convert that NumPy array back to a tensor. And then we call the tensor method on it, function on it, constructor, and it will create a tensor back. So we have a XX tensor and YY tensor. Once again, you can feed it directly into your matplotlib, and it will do that. So here we go. This brings us to our first lab. This is your turn. Just imagine, create a function of your own that you like, and plot it out, and write the NumPy and Pytorch code for it. Pick your favorite function. You can take it in 1 variable, 2 variable, whatever you like, right? And create this. And guys, this is your first lab to do that. And so with that, I'll take a 15-minute break. Well, let's regroup. It's 8:30 in my clock. Let us regroup at 8:45. In the meanwhile, sort of review it and see, guys, if you can run this code, can you create any function of your own? Or try to take something complex and see if you can write the NumPy and the Pytorch equivalent of it. So you will realize that learning Pytorch is a no-brainer. It's very easy. If you know the rest of basic NumPy, you know it. And NumPy itself is just a set of very simple functions, NP dot, all your mathematics, high school algebra functions, trigonometry and algebra functions on numbers. As simple as that. Any questions, guys, before I'll open 1 minute for questions before we take a break? Anybody would like to ask a question? All right, guys, in that case, I will stop the recording and I'll stop the live stream. And good. Are you guys seeing my screen?
Yes.
Okay, wonderful. So let's get back to where we were. We were reviewing the Pytorch, and the statement that I was making is, it is something new for all of us, but if we put in a bit of effort, it is not as scary compared to other frameworks go. Pytorch comes as a pleasant surprise. You can pick it up very, very quickly. So with that, hang on, I just make sure that I don't hear my own echoes. So that's that. Now, let's go and do something useful with it. I'll just do or cover 2 more topics today. On Monday, I talked about using some trained models. You know, I spoke that some of these models are ginormous, and it takes a lot of effort to train them. You need enormous computing resources, you need a lot of time, and finally these models get trained. The GPT-2s, GPT-3s, the BERTs, and the AlexNets. These are not something you train on your own machine usually. So what you instead do is you take this, people have shared the trained models, the big guys, they have shared it into the open community, and you take those models and you either use them directly or you just tweak them. You do a final layer training. So what you do is it's been trained for one problem. Your problem is different. So you chop off the head, you take the headless version of it, attach your own head, specific to your problem, and then you train just the last few layers, last layer or the last couple of layers. And that training you can do on reasonable hardware and use it. So that is called fine-tuning. People often use the word fine-tuning BERT or something like that. You'll often hear the phrase. That is what is meant. So today what we will do is take, not BERT, we will take the image processing models, the computer vision models, and I will show you how we can use it to recognize animals. So towards that, you go into this directory pre-trained, you will see this notebook, ImageNet pre-trained. So let me explain what that means. There is an ImageNet standard library. It's a library of a vast amount of pictures of things, animals, houses, whatnot. Stanford maintains something called a WordNet, a vocabulary of things and nouns and things, basically dogs and whatnot. And there are images gathered here for each of, or most of those things, a vast number of those things or words, they're images. So the problem is, given a picture, you have to tell What is it? Is it a dog? Is it a cat? Is it a duck? Is it a house? Right? What is it? And it has to be one of the finitely many things. So when you take an image and you recognize it as one of the many things, the target variable in the way that we look at it in machine learning is it a real valued or is it categorical? Anybody?
Categorical.
Categorical. So ImageNet is a collection of images, and if our task is to find out what is each image of, is it of a cat or dog, it's a classification problem, because the target variable is a set of classes, set of identifications or types. It's a classification problem. And so we take this notebook is called pre-trained, I call it, just to emphasize that we will not do the training part. And those of you who have been doing workshops with me, you'll be surprised. You'll say, how can you have a model that is making an inference which you haven't trained? Don't we first take the data, visualize it, clean it, and then train the model? And after training the model, we look at model performance, and then we go and use the model to make predictions. And the beautiful thing is that somebody has already done that hard work for us. Somebody has cleaned the data, somebody has pre-processed, has trained this model, has verified the accuracy of these models. And these are, I will give you a little bit of a history of these models. These are the models that have they have broken world records successively. So these are the models that have made history in this field. And what are we doing? We are just literally taking the model and directly using it for inference. Even on a purely electrical computer, for example, it will work just fine on your laptop. So to make your life easier, I have wrapped it up, because at this moment, not all of you are very familiar with Python and so forth. So I've taken away the complexities of it. And it is in this class, ImageNet Recognizer. You can go and read the class. So I'll give you an idea where that class is, ImageNet Recognizer. If you go, remember all of these classes are in SV library. So there, if we go and to where we go, transfer. ImageNet, do you see this ImageNet class, library, or sort of module? In this, do you see the ImageNet Recognizer class? In Python and in Java and C++, there is a concept called object-oriented programming, which means that you should bundle up your code in proper, well-defined classes. I won't go into that, we'll cover it over the weekend, but this is your ImageNet Recognizer class, and the code is straightforward, but at this moment it won't make sense because we haven't covered this theory, which we'll do in successive weeks. But our goal today is just to get started. So we will get started. Here, we import all of these libraries. Once we, what are the libraries we import? The pandas, the NumPy, matplotlib, all of this usual stuff, the torch. And now Pytorch comes with a special library for computer vision. It is called Torch Vision. And in Torch Vision are these pre-built models, pre-trained models. You can just directly import it. So when you run this notebook, a couple of warnings. Run it on a machine where you have a lot of space, because when you run this thing, the first time around, okay, so I have to give it import sys. I should just say import sys here also. So guys, make this correction. In this, I forgot to put this first sentence, import sys. Right? When you do that, in my case, it ran in what, less than a second? The reason is all those big models have been downloaded. When you run it on your machine, it won't be that quick. It will take quite some time to run. But let me tell you what models we have. There are words like ResNet, ResNet, small ResNet, big ResNet, VGG 11 and 19. These are different generations of the VGG, AlexNet, DenseNet, and Inception. So I'll talk a little bit about it. Inception is the biggest of them all. It's the most recent. It came out of Google. It is a ginormous model for image classification and image tasks. It took a very, very long time to get trained on huge amount of hardware and finally got trained. So they have shared this model. We can use it directly. ResNet is the one that is interesting, and we'll talk about it. I believe the history, and I might get the dates a little bit wrong. AlexNet surprised the world by breaking the image classification record in 2014. That is when people realize, many people say that deep learning, while it was a subject that people were working on for a long time, let's say it has a long history going back into the 80s. But the business world, the industrial world took it seriously, sort of when the AlexNet came about onto the scene. In 2014, it broke the benchmark record in a most impressive manner. After that, successive architectures have come. Each of these are neural network architectures. After that came ResNet and VGG, both of them actually from Microsoft. I believe must be different teams, I believe, or 1 year after the other. I forget the exact history. These were, again, big ideas. ResNet introduced the concept of short circuits or residual connections, a very big idea in the world of deep neural networks. It has a lot of implication. It made possible creating really deep networks became possible because of residual connections. And the ResNet architecture brought it about, right away broke records. ResNet 18 and then ResNet 152 is, of course, as you can imagine, 152 layers deep. Really deep neural net. VGG, again, winning architecture, and then its latest version, I believe, is VGG 19. It's built in. So that's the history of it. And DenseNet is standard DenseNet. I believe it has some residuals and so forth. So these are the architectures, guys. These are the sort of architectures, each one of which takes an army of AI researchers, vast quantities of server resources, hardware resources, and a huge amount of time to train and build. So it is really good that these are now available free of cost for you and I to use, and we are going to use that. So how much does it take? You can see it just takes a few lines of code to do that. So what we will do is, because these architectures are trained, we will use it easily. First, let's look at the lines of code. Here, what am I doing? I'm just instantiating this class that I have created to take away some of the complexity. And please do go read that class. If you are familiar with Python or have some background in machine learning, those of you who took ML 100, 200, should go and read that code. Once you become familiar with Pytorch, it will look a lot easier. So you instantiate this object, and then you ask it to tell how many models has it built in. And you realize that it has all these famous architectures built in. Then, and I have not used all of them, some of them. So then I picked a few of these. And then I say, these are pre-trained models. Let us say how well these models do if I show them some image. So now the question is, let's go get an image. So here's the URL of two images. One of them is a duck, and the other one is, I believe, oh no, it's a duck. I shouldn't say tree. I apologize. Duck. I should say duck. Please correct it in your notebooks. Duck. So as you can see, it will render a duck. But if I change it to here, URL, I make it to dog URL. I can choose which of the two I want to do. Then you'll see a picture of, let's see, hopefully a dog somewhere coming up. Yeah. Ah, really cute looking dog. A golden retriever. I suppose many of you know that I own a golden retriever. Looks very much like this.
Yes.
So you take this image, and let's start with the golden retriever. And now let's go to the model. And here's the thing, guys. We are not training this model. It's pre-trained. Nothing has to be done. Just directly go ahead and use it. And it's amazing. See, this model has not been trained on this picture or on the picture of the duck. It has been trained on different pictures. But let's see how well it generalizes and works on this. We will try each of these models and see what happens. Now for each model, we'll ask it to make 5 guesses, the best guess, second best guess, and so forth. Let's see what it comes out with. Oh, I think I have not run some part of the code. Did I? Yeah, I have to go and run it from the beginning. Let me run all of this. There's.
Asif?
Yes?
How do you import SV learn?
So the way to do that is just literally in the very first line. Do you notice that? You explicitly give the path to it.
I see. So we have to give our path, right?
Yeah, your path. You'll have to modify it. Thank you for bringing that up. Huh? So just go modify it to whatever your place is, where you install this. You unzipped it, right? Give the path all the way to the deep learning workshop directory. That's it. Because svlearn is sitting in this directory. All right.
So do we include everything after C drive, right? Whichever drive we have.
Yeah, that's right. Start with that. So in Windows, it will be C : blah, 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 blah. And then finally / deep learning workshop.
Also, we include the C : as well.
Yes. Windows, I would imagine you have to. Okay. So here we go. So this is it, the dog, I believe. And then let us run this model. Look at this. Look at this, guys. The first model, which is actually, I believe, the ResNet or the AlexNet. Which one is the first? Let's go and see. First is ResNet 18, a very small model. And that very small model is already able to tell that it's a golden retriever with 98.9% probability. And then it says that there is a small probability that it might be either an Afghan hound or a Cocker Spaniel. Let us go and see what a Cocker Spaniel looks like. See if it is making sense at all or not. So I'm going to go and Google a Cocker Spaniel. And this is how a Cocker Spaniel looks like. Would you guys agree that it looks somewhat like a golden retriever?
Yep.
Like, look at this. There's some similarity to it. So you imagine that it sort of makes sense that it did that. What about the Afghan hound? What in the world is an Afghan hound? Let's go find that out. Well, that is the third guess. It is pretty hairy, I suppose, which is why the AI is thinking that it might be an Afghan hound. Do you see, guys, how it is reasoning? You can see it think. If you look at this picture of an Afghan hound, you would see some similarity to a golden retriever, isn't it? Right? And so this seems to be working. And the fourth and fifth, and then here's a surprising thing. It says it might even be a tennis ball. Can you guess why it is guessing it might be a tennis ball?
Fuzzy.
Yeah, because dogs often play with tennis balls. And many pictures of dogs have a tennis ball somewhere in there, either in their mouth or next to them. Right? But this is the simplest model. Now, look at this. The next best model, a bigger version of ResNet gets tennis ball as a second probability, but it says 99.4%. Let's go and look at the state of the best model. Look at this. Inception is saying that for 99.997% probability, it is a golden retriever. I suppose at this moment, and the next probability comes, Cocker Spaniel is at 0.0009%. I hope you guys would consider this, that if you have to approximate it to 3 decimal places, you would say that golden retriever is pretty much a certainty and others are practically 0. Do you see that, guys? Now let's try our luck with the duck and see how well it does the duck. It's a mallard. I don't know exactly the biological difference between a duck or a mallard, but I'll call it a duck. Let's try our luck with this duck. And, by the way, do you guys see how instantly it did the recognition? in the blink of an eye. I'll do it again, see how fast it works. And I'll just shorten the screen a little bit so that you can see it run. I'm going to go here and I'm going to first clear the output. Yeah, there is no output here. And I'm going to run it now. Ready? There we go. You notice instantly the results came. All the 5 models made their prediction. And then what you see is that they are all saying that it's a drake. Oh goodness, that is what it is. When I was looking on the internet, I looked for duck, but I got the picture of a drake, and this is it. 99.99968% probability. What is the second best probabilities here? Plunger, helper. I don't know why it came up with that. Lakeshore with the probability. So is it a lakeshore, guys? Does it look like the lakeshore?
It's sitting on it, yeah.
Yeah, if you take the duck away, what you are seeing is a lakeshore. So this is how the deep learning works. And isn't it amazing that today we take this level of extreme accuracy for granted? This is what this deep learning subject is about. That's why it's changing the world. Now we are in the world in which you could be driving around in a car and it is looking at the scene in front of it while you're going 60 miles an hour, and it is doing recognition and segmentation of images. It's dividing the scene into objects and recognizing each of the object at full speed. Right? That is our state of the art. So when we dream of self-driven cars, that's what we are asking for. We are asking that the machine should be able to do that. And it is able to do that. So here we go. I've just taken all the guesses of the different models just for you to compare. Like for example, Drake, you can see that this model is...
Font size.
Increase the font size, right? Yeah, hang on. A little bit smaller, maybe. Yeah, let's look at this. Maybe a little bit smaller, yeah. Is this visible, guys, now?
Yes.
Yeah.
It's good.
Yeah, so I hope you all agree that these are extremely, very, very impressive identifications. So the homework for you here, guys, is, I forgot to write the homework, is to go and pick your own images from the internet, insert the URL, and discuss. So may I request you guys to do one thing. Each one of you pick one image from the internet, feed it into this code, run it, and in the social forum, discuss. Post your image, say this was the image and these are the results I got. Could you please do that, all of you? It will be interesting, instructive for all of us to see. If we get 30 different objects, we can see where the AI is strong and where it is weak. So there are areas that it is weak at, and I invite you to go find those areas and see where it is strong at. So that's that is for pre-trained. Now, we talked about transfer learning, using other people's work. And I hope this was an impressive example of that.
So, Asif, one thing I'm not able to understand is how is it, what is it trained on? Is it trained on all Google images? Or?
ImageNet, the entire ImageNet library. So what is ImageNet library? Hang on, let's go there. So what happens is, for research purposes, researchers have created, with great effort, data sets. In the world of machine learning, the hardest part is gathering data. It is the algorithm is one part of it, is the exciting part of it. But the dull part, the boring part, is preparing data, right? So look at this. This ImageNet is an image of 14 million images. 14 million images have been created. And you can explore this ImageNet structure as a cloud map, download it, and so forth. Download, you need permission. I do have permission for that, but you can get it. Challenge. So every year, do you notice that there is a challenge to do this? In 2017, after 2017, do you notice that there are no more ImageNet challenges? Which algorithm will do better? There is a reason for it. I don't think they have done it because the algorithms have become so good that they are achieving near perfect accuracy now. This problem is too easy, way too easy for the state-of-the-art algorithms. But if you go back to 2010, let's go back to 2010. And you will realize, I don't know what the state of the art was, but the state of the art wasn't that good. You can go back and look at the accuracy. September overview of results. Here it is. Large-scale ImageNet recognition at that time. Knowledge. Let's see what the numbers were then. This year's challenge, leave categories, teams. So you see that the teams are all impressive teams. The who's who of big research groups in this field. Global teams. And the winner was Urbana-Champaign, I'm proud to say. I'm an alumni from Urbana-Champaign. Ah, nice. And you see that, flat cost with prediction, computation. Well, in this case, they said how well you can do. So you can see that some of the hard categories, the predictions are only 92%. They are like this tree, 86%. It was already getting better, but, oh, these are error rates, or maybe these are error rates. These are not, otherwise it wouldn't make sense. Easy categories is 0.12 error rate, but in hard categories, very, very high error rates. But today, if you look at the results in 2017 and thereafter, we are near perfection now in these categories. So you got that, Nisarg?
Yeah, thanks.
And you'll get more of it. As we see, we haven't gone into the theory. I'm asking you to do the labs before you learn the theory, because it's important to get started. So likewise, there is another data set, which is a bit easier data set. It is called the CFAR data set. This is the code for it. And the code is not hard, but at this moment is just barely a couple of hundred lines of code. Half of it is just comments. You can play with this, but let me go to the notebook and show you it in action. So you can go to CFAR 10 notebook. And I'll just walk through it here. We take this CFAR. First of all, obviously, you have to once again add it to the path. I've made it easier for you. Just go create the CFAR classifier. You can look at its architecture. Actually, I backed the CFAR dataset with a very, very simple neural net. As neural nets go, guys, it's a very simple neural net. It has 2 convolutional layers and 2 linear layers and 1 output layer. Right? In the world of neural architectures, this is almost a joke. Still, let us see how well it does. So this is your example of creating your first classifier using a neural net. But once again, because we are playing with it, we have no idea what convolution means or linear means. At this moment, just play with it. So what do we do in machine learning? We train a model, and here, the new thing we do is we actually train it. We don't take a pre-trained model. We train it, and then we evaluate its performance. So there are 10 objects here. The 10 objects are ship, car, and basically car, ship, plane, dog, etc., etc. And you have to identify one of those 10 objects. You can look up into the classifier. We'll tell you what the labels are. I should have printed it out. These are the labels. In fact, here in the code, somewhere the labels should be there. Did I not put it? Yeah, here. You have to identify it to be a plane, car, bird, cat, etc., etc. So therefore, guys, is it a problem in regression or classification?
Classification.
Excellent. So we will classify. We train it for 1 epoch. 1 epoch means just 1 times we cycle through the data and no more at this moment. And then when we evaluate its performance in 1 cycle, let's see how well it does. This time when you do it, let's see, I'll show you the whole code in action. Here it is. Do you notice that it is busy downloading this model? Right? This will happen in your case also. It is getting the CFAR dataset, CFAR 10 dataset. There's also a CFAR 100 dataset, which is much bigger. You can have fun with that. Let it go through. So at this moment it's downloading, then it will be ready with it. There it is. It's extracting it. Got it. And it is saying that this is a simple continent. And I invite you to go change this code a little bit. Let's train this model. And now it is training. It is running through the epochs, the different steps through the epochs. Oh, it finished training. Right. Now let us evaluate its performance. Let's see. Oh, here are the things. So when you evaluate its performance, let me walk you through this code. This is easy, right? You train it for an epoch. Now what you do is you take a batch of data, a small mini batch of data from the test. Usually when you train a neural network on a data, training data it is called, you can't take some examples and ask it to tell you to identify those because it might have memorized it. It might have overfit the data. If it overfits, overfit becomes somewhat like not learning but memorizing the answers. So you can't evaluate a model on the training data. You should evaluate a model on the test data. Right? So we are picking up test data, some test data. We take one batch of test data. One batch, in this case, is about 16 images. We use the classifier to make predictions on those images. And you notice there, guys, I'm saying classifier device. Why? Because it makes predictions much faster on the GPU. So what this code will do is, if on your machine it finds a GPU, when you run this notebook, it will automatically go and grab it and run it in a fast way. If it doesn't find a good GPU, it won't go there. Now, bad news for those of you who are running it on Mac, even though you have very good graphic cards on your MacBook Pro, it will ignore it because deep learning is not supported on Macs at this moment.
Asif, line 3 is giving an error. It's saying no module name torch.types.
Which line? This one?
Yeah, the SV learn datasets one. Line 2, sorry. Yeah.
Oh, yeah. So here, you're looking at this class, right? CFAR10 IPy.
Yeah, so I'm trying to import CFAR10 classifiers, simple CFARNet from SV learn datasets, and it's giving me.
Oh, right here it is. It means that you haven't run this line. You have to make sure that this works correctly for you.
No, I ran that line.
And it is giving problem.
It's saying no module name torch.types.
Oh, then your Torch installation has not succeeded.
But it Torch worked on the other one, the ImageNet.
Did you install Torch Vision?
Yeah, I did.
Something fishy. Huh? We'll have to debug what's happening on your machine.
Oh, do we need to import Torch and import Torch Vision here before then?
You don't need to. If you want, you can, because this class CFAR10 classifier under the covers does go and import those.
Oh.
You don't need to do that. So then I don't know why it is not failing out on me, but yeah, we'll figure out what is happening on your machine. Right? Is anybody else having problems, guys?
Yeah.
You too? Oh, okay.
I installed svlearn, but now I'm getting a no module named svlearn.transfer, which is strange.
Okay, so we'll need to sit and see what's happening on your machine. Yeah, just give me, maybe stay back after this class and we'll do that. We have some time. So then one of the things you do, and this is something I wanted to mention. See guys, we trained it for an epoch. We evaluated it. This is the evaluation loop. Huh? We make some predictions and then we count how many predictions were right and how many were wrong. So here is it. This is a bit of Python code. It says that I gave you a cat, what did you predict it to be? So the way to interpret it is cat was predicted as cat, ship as ship, good. But one ship was predicted as car. So it got confused between a ship and a car. This looks right, this looks right, this looks right, this looks right, right? Oh, cat got confused as a dog. Cats won't like that. Car was fine, plane, truck, dog, horse. Truck got again confused as a car, and a ship got confused as a cat. Now that is a blunder. So what is the accuracy? It made 4 mistakes out of 16. So your accuracy is 75%. Right? So guys, how can we make it better? It's a question worth asking. And this is one of your homeworks. You have to try it out. The way to do that, but I'll give you an answer to this by a hint. I just run it for one epoch. It saw every piece of data only once. What happens if I show it the piece of data not once but twice, let's say? Let me run it here and see what happens. You can see that it's running through its steps.
Yes.
Right? And by the way, guys, this thing will run a lot slower if you don't have a GPU. Make sure you have. And now what happens? Inference. Oh, do you notice that the number of errors came down? It became 5 out of 16. So accuracy has gone up. Oh,
no, it's gone down.
It's actually, well, it's a random process, right? So the lesson is actually the opposite of what I want you guys to learn. Because I have reasonably good hardware, I'm going to run it for 10 epochs. And let's see what happens if we run it for 10 epochs. It cycles through the data 10 times. And it's a vast quantity of data, remember. So do you notice that the loss is coming down? It started out with the loss of, well, it actually started out with a huge loss, but within 1,000 steps, it came down to 1.2. And then it is continuously decreasing. The loss, what does the word loss means? Think of it as the amount of mistakes it is making out of those millions and millions of images, tens of millions of images, how often it is getting it wrong. And well, actually, it's not how often, it's more complicated. It's cross entropy. We'll learn the concept of cross entropy next time. There we go. We finished this model. Let's try our luck, evaluate. There we go. Oh, sorry, I started the training again. All right, we'll wait a little bit, but in the meanwhile, let me talk about this while it's training. See, guys, when you train a model, as you can see, it takes time to train a model, right? In this case, I've given a ridiculously simple neural net, 2 convolution layers, 2 dense layers, and an output layer, right? In the world of modern architectures, this is almost laughable. But what I want to show you is 2 things. First is that training a neural network takes time. You can see that even on a pretty powerful hardware, and the hardware that you're looking at on my machine is actually, it costs tens of thousands of dollars. It's a full, powerful deep learning workstation, and still it takes time to run. But when it runs, now we run this. There we go. It still comes out with 6 errors. Right? So I'll let you play with this and see what you can make out of it. Right? How you can reduce these errors. You have to figure out the tips. It is 62% accuracy. And it will vary because you're taking random samples and doing it. It will vary. So when you take a model that takes a lot of time to train, especially if it has taken a month or weeks to train, you don't want to throw it away. You want to save it. So the first thing you do is you save the model. This is what you do. In the lab, you build models, the best model that you can, and then you save it. And then what do? You go to production with it. So we are going to save it. Saving it is easy. You just save it to a file. Here I saved it to this file. Right? Now what happens? What will it say? What does it mean to save the model? A neural network is made up of a lot of weights, what are called weights or parameters. And it will store the value of all those parameters. Even for this simple neural net, if you look at the number of parameters, it's actually huge. Then when you take your model to production, so here it is, you're done with the development. You're not talking about it. You have given it to a different team. That team is taking it to production. And usually the people who take your model to production do not know artificial intelligence. Their job is to blindly just use whatever model you give them, and they will use to make predictions. They'll load it up and they'll use it to make predictions. So they will do this. They will load the model at inference time. They'll maybe load it into their microservice, your Flash application, your Fast API, your Tomcat, your whatever. And these models can be loaded in Tomcat. Neural network models are very portable across languages. You can do that. There's an Onyx format. So you can then load it. So now guys, I have a set of homeworks for you. The homeworks are the following. You read the source code of CIFAR 10. This source code I'm saying, just read it. Now the CIFAR 10 source code is not that hard. The first is the neural net. This is where we build the neural net. You won't understand it, guys. At this moment, I haven't explained the theory, but start by just reading it. See if you can get a bit of a sense of what it is doing. Here, it is using a base class, CIFAR classifier that I've created, which is doing most of the heavy lifting. Here, there isn't much code. If you put in a bit of effort, you'll understand it. The main here is exactly what you find in your Jupyter notebook. So it is not that easy to, it is not that hard, but it will take you time to read this class, especially since you don't know the theory yet. Try to make some progress, and then play with the number of epochs. What happens if you increase the number of epochs? Right? See what happens. Does it improve accuracy? How many epochs does it take? Then, what happens if you change the learning rate? The constructor of the CIFAR has a parameter called the learning rate. Keep the learning rate between 0 and 1. Learning rate is never more than 1. So between 0, what happens if you make it 0.1, 0.01? Take it in powers of 10 or inverse powers of 10. See what it does to your accuracy of your model. What happens if you change the mini batch size? So if you look at this, a neural net, the way I've constructed it, you can actually give it different sizes. Do you notice that? Where are we? Okay, this is in the base class, so I should go back to the base class. Yes, we learn. So it's a little bit of a code that you will have to gradually get used to. The base classifier. So this is something, read with caution in the beginning, right? It may take you a little bit of time to get your heads around. It takes a neural network, there's a mini batch size learning rate, but the way you would do it is, you would just go to the code here, where you say, where did we construct the classifier? Right here. You want to give it a different learning rate, you can say learning rate is equal to 0.1, right, or 0.1, or 0.1. Let's say that what happens if you give it a huge learning rate? Train this model. You notice that it's going from much bigger loss to it's making slow progress. Let it make progress while we continue discussing the rest of the things. So play around with it, guys. These are called the hyperparameters of the model. And usually when you train a neural network, even when the architecture is known, there are a lot of hyperparameters that you have to search and find the value of. Are we together? Okay. So that's a thing. And lastly, this is challenging. Do it only if you're very comfortable with Python and have some exposure to Pytorch. Go and tweak the underlying neural net. There is a class called Simple CIFAR Net. I've made it very simple. Try to add more layers, bigger layers, and so forth, and see if that improves the accuracy of your model. Does it do better? Make sense, guys? And now, this is for image processing. I want to show you now some things to do in the space of natural language processing. In the natural language processing, actually, I've kept it very basic at this moment. There are only two things that you should focus on, and I'll talk about that. One is, well, don't read this code. No, sorry, I take it back. Go away. At this moment, forget about this code. Go back to the notebooks. NLP, 3 things. First of all, there are many NLP libraries. The libraries that are very popular these days is NLTK. It's written in Python, it's very Pythonic, it's easy to understand, it's complex. It's slow, it's very, very slow because it's written in Python. A text blob sits upon top of NLTK. It makes NLTK manageable and simple. Always start with text blob, it's very easy to use. And vocabulary is simply the vocabulary. You can ask for any word. It's a dictionary. You can ask it to give you the meaning, the synonyms, the antonyms of a word. It will give it to you. Now, the industrial strength libraries, the ones that you actually use in production. So most people, they tend to use NLTK, and you see a lot of NLTK code on the internet, and that's all right, tutorials and so forth. But actually what you use in production is not NLTK, it's very slow. You use these two libraries, Spacey and Ginseng. These are libraries that are industrial strength, and they're very opinionated. They have only one way of doing things, but they do usually do it right. And Spacey in particular has a very good integration with the transformers. Because it integrates with the state-of-the-art transformers, this giant pre-trained models, you literally get high performance efficiency with whatever project you're doing in a matter of a few lines of code. So here I'm just introducing the text blob. This is your hello world of getting started with NLP. So you run these libraries, you'll do that. I took this quote. This is from the author, Charles Dickens, a British author. His book, A Tale of Two Cities, starts with this beginning. It's a famous beginning. You must have, it's become a cliche, and you must have seen it at many, many places. It was the best of times, it was the worst of times, and so forth. And this is one of the last paragraphs in the book. It's also a memorable paragraph when the hero, the protagonist, is sacrificing his life to save the husband of a girl he used to love and so forth. So then these are the last few lines. It is a far, far better thing I do than I've ever done and so forth. And so what we will do is we will look at this. How many sentences are there? Unbelievably, this entire paragraph is one sentence in Charles Dickens' book. And this is another sentence. So we will ask this library, we will give this library this text and ask it to just tell us the first 10 words and identify what they are. So as you can imagine, it is able to do it. It is a proposition, was, these are all symbols, times, PR, etc. So these symbols, you can look up there in the dictionary. Worst is an adjective and so forth. It will tell you that. Now you can ask it to give you the noun phrases or verb phrases or adjective phrases or whatever it is. And then it is trying to do that. There is a typo here, likey, it has interpreted as noun. The rest of it, it seems to have gotten right. Darkness, a present period, noisy authorities. Well, it has included the adjective also. Noun and adjective. Superlative degree seems to be doing pretty good. If you ask it to do sentiment analysis, is it positive or negative? Again, guys, it's a no-brainer. It's absolutely a no-brainer these days. It is saying that the first paragraph is essentially neutral. Would you agree that it is neutral? Every positive sentence is cancelled by a negative sentence. Do you see that? Best of times, the worst of times. Age of wisdom, age of foolishness. Belief, incredulity. Light, darkness. Hope, despair. Right? Which is why I chose this, just to show that how well the sentiment analysis looks. So the polarity, it is saying that this sentence is neither positive nor negative. It has close to zero polarity. Would you guys agree with that it's correct for this text?
Seems so.
Yeah, seems so, right? Is it a subjective sentence? Subjectivity is low. It was the best of times. Not very subjective. Right?
What is subjectivity?
Subjectivity is...
it's opinion, isn't it?
Yeah, lack of... I mean, in other words, it's one perspective. One perspective of it. One person's perspective of it. Now, you look at the second sentence, though. It is a far, far better thing that I do. Do you see the subjectivity here? Than I have ever done. It is a far, far better rest that I go to than I have ever known. One would imagine that this is definitely subjective. Let us look at it. Polarity. It is a positive statement. Well, it's a beautiful story. A person is being guillotined, head is being chopped off, and he is thinking these thoughts. positive sentiment, and subjectivity, it's highly subjective statement. So guys, play around with it. Feed it your own text. This is something for you to do today. Feed it your own text and see how it works. But the point I wanted to make today, or the purpose of the first week, is you can do a lot of practical things without, even before you have learned deep learning. Just enough, you can be productive. The libraries are excellent and you can start marching forward with it. Bear with me, I have another 15 minutes and I'll show you some more magic. Language detection. We asked this thing to tell what language it is, and it seems to say, this has been written in English. Now here is something for you to do. Go translate it into some other language. We ask it to translate it into Hindi. Now, how many of you in the audience know Hindi?
Me, sir.
Yeah, quite a few. So those of you who know Hindi, read it and tell me whether this looks like a reasonably good translation.
Okay, but not so like in the first line it says vah means he, right? And then in the second line it is, and second line onward it is yeah means this.
Yeah.
यह प्रकाश का मौसम था is not right, sir. यह प्रकाश का मौसम था is not correct.
Yeah, that is not correct because it's a literal translation.
Yes, sir.
So, and then we will do transformers and other things. So this exercise, which we have done with a very easy library, which is text block, we will repeat with some of the state-of-the-art transformers. All right? And we will compare the results. But even as a baseline result, it's not that bad, is it? Would you say it's terrible? I would say it's pretty good, isn't it?
Yeah.
This is for something where we haven't even used the state-of-the-art neural architectures. This is a very easy library, text block, and we have used it, which uses a simple, it does use neural network, but a simpler one. And then in the coming weeks, we are going to improve upon that and see where it takes us. But something to get started with. We look at the tokens, we ask it, what are the sentences in this text? And very clearly it says there are two sentences. One sentence here, from here to here, and another sentence, it is here, which to me looks correct. You ask it for the words and right away it breaks it up into the words. Right? And you can play around with it, guys. So this was a one library text blob. I would suggest that if you're starting with natural language processing, text blob is your friend. It will help you gain confidence on day one. Just looking at this code, guys, how many of you feel that yes, natural language processing is so easy that even we can get started right away and be productive, even when we don't know much?
Starter notebook, sure.
Yes.
Just one observation, sir, here.
Go ahead, Pradeep.
So I am doing one assignment for college where they asked to do the same thing using MetaPy, and the functions and the everything tokenizer, everything looks very much similar.
Yeah. Most APIs are similar. Yeah, it is. I mean, see, NLP has only so many ideas. You tokenize, you clean, you remove, you do stemming, lemmatization, you remove stop words.
That's right. Yeah.
How far can you, and then you start doing your real work after that. Text classification and so sentiment and this and that. All right, so this is that. The reason I mentioned it here, I didn't bring in Spacey, etc. It's a little bit more complicated. Every week we'll try to introduce ourselves to one more library as we make progress. But I hope today we have introduced ourselves to quite a bit of things. I would like to take the time to introduce a couple of more things just to show you the magic of this thing. Here we are going to find keywords. And we are going to use either Gensim or something called Rake. And there are many, by the way, many libraries, but Gensim is pretty powerful. So I have text. If you look at the directory, you will find 5 different files. Shakespeare sonnet. These are, by the way, some of my favorites. So you are seeing a very biased selection here. If you don't like this, I ask for your forgiveness. Shakespeare sonnets. Long ago, when I used to have black hair and I was a teenager, I was absolutely in love with Shakespeare sonnets. I would print it out, I would post it on my wall, I would look at it and so forth. So, well, They are there. The other is the US Declaration of Independence, a profound document. Right? It's a democracy, the largest democracy that being born of this document, certainly worth it. Tale of Two Cities, we just went through it. Gettysburg Address. Those of you who know the history and the Civil War, of course, it hardly needs to be explained. And when India came out of colonialism, right, after almost 200 years of oppressive rule, the speech that the Prime Minister of India made at the midnight is the tryst with destiny. Right? So these are the 5 texts I chose. And I want you to do this, guys. Change this value. First of all, make it your directory. Change these values to your stuff. And ask this library to find the keywords in it. And the 2 libraries are either Gensim or Rake, R-A-K-E. You can give it the 2 words. Now here, I've run it with this. This is a huge amount of sonnets, the sonnets, and I will go straight to the end. Right? And what does it say? Let me see. What does it say at the end? The last sonnet is somewhere here. Obviously, there's a copyright notice also here. Yeah, this is it, the last of the sonnets. But anyway, it's a little bit archaic language, but it found these many keywords. Those of you who know Shakespeare would immediately recognize these keywords, thy, thou, etc. Now, if you look at this, you observe something. This thing has been trained possibly on modern English. So it is picking up thy and thou as keywords, and doth and thee as keywords, and shall as keywords. Well, Americans don't use the word shall. So it popped out as keywords. Are they really keywords? Or should you put it in stop words and remove it? Right? Because in the Shakespearean time, the word was thou, actually. I remember even now when I read some of the older British books, up to almost 1950, I would imagine, 1940 or 1930, it was still common to call your sweetheart thou instead of you. You was more impersonal, thou and thee was much more sweet or personal. Obviously, those words have gone out of usage, but in something so beautiful as poetry, they surely show up. But anyway, your mileage will vary. So go play around with these keywords. But it's amazing, isn't it, that it picks out the keywords in a text. And the last one is something very interesting. It is the beginning. We will develop it more. It's actually one of the projects we are trying to do in my day job also. Suppose you get a piece of text. You ask this question: how readable is it? Like, is it something that a kindergartner can read? Is it something that a 10-year-old can read? 6th grader, 5th grader can read? Is it something that a high schooler can read? Does it need college degree? Or does it practically need a PhD? Right? So there are libraries that do that. In particular, there are 2 generations of libraries. One are the statistical libraries. For many, many years, since 1940, people have been creating all sorts of tests. For example, this flesh reading ease test, it's been there, I believe, since 1940. And it all tells how much education you need to be able to understand a text. Right? So I invite you to go and figure it out. Here, I took Lincoln's address. Lincoln's address, when you do a score off, it turns out that a high schooler can understand. Now, Kate, would you agree with that?
Yes.
It sort of does that. But what happens if we try the US Declaration of Independence? That could be a tricky thing. Let's see. Or what happens if we try Shakespeare? Well, we tried Shakespeare. Let's try something else. Suppose we put it here in contrast and see what happens. I'll have to run this thing from the beginning. Oh, something went wrong. Text is not found. The model text stat has no. attribute. Okay, I'll have to go to the code and comment out some of the newer. See, there is a new version. I used alpha version of the next version of the library. Bad idea. I shouldn't have. And because of that, this has happened. But when you do that, I'll tell you what the result is, and you should try it out. So guys, let me tell you, accidentally, I didn't comment it out. Please do this right away in your code. Go to your code, and I'll post an update with that thing removed. When you go to NLP, readability, you see this code, readability.py. In this, comment out the last 1, 2, 3, 4. The last 4 lines here. Guys, can you see my screen?
Yeah, hold on.
Right. Comment it out, guys. Okay, Kate, would you mind posting these things in the forum?
I'm taking some screenshots. I'm kind of getting a bit behind.
Yeah, so
the directory.
Right.
I'll try to get what I can in the forum.
Yeah, that's right. All we need to do is comment out the 4, and I'll post the new version of the code if needed for this. When you comment it out, you realize that the readability, it's the US Declaration of Independence is much harder to read than the Gettysburg Address. And when you feed it Shakespeare's sonnet, it becomes extremely hard to read. Right? I believe it says that you need 100 or 200 years of education to understand Shakespeare. Perhaps that's one reason why Shakespeare is not popular these days. Right? So play around with it, guys. And by the way, once you comment it out, play around with it. I'm almost done showing you the
as if it still didn't work even after commenting it out.
Oh, you have to restart and run the kernel.
Oh, is it?
Restart and run the kernel. It will work for you. Then, because it's still holding on to the old compiled Python code. So guys, that's there. There are a couple of things. We didn't do auto machine learning. Should we keep it for next time? Because we are out of time now. So automated machine learning is something. I'll just give you a taste of it. Remember I said that in a model, you can have a lot of hyperparameters to learn. So how do you not have to learn all that? So let's do this. I want to do it properly. I don't want to do it just like this. Let's keep it for next time. We are running out of time. These are libraries that do automated machine learning. Let this be. There is one more thing that I can squeeze in quickly. I told you that for visualization, Matplotlib is a baseline library. There's Seaborn, there's Bouquet, there's Vega. They're beautiful libraries that people can use. Those of you who are familiar with ggplot would be pleasantly surprised. We have a lot. Altair is actually its equivalent. It's based on the grammar of graphic. And the way it is based on the grammar of graphic is that there is a JavaScript equivalent of the grammar of graphic. It's called D3, D3.js. Very popular library for visualization. But Vega takes it further, one step further. It creates a very structured approach to creating visualization. And now they have even simplified that with the Vega Lite they're coming out with. So Altair is based on Vega and Vega Lite. And I wanted to show you some basic examples of using Altair. And in the interest of paucity of time, I will not run it right here. Just assume that it is run because we have only 2 minutes. So just look at this. Suppose you want to create bar charts, right? The way you interpret, so these are the imports, enable, this is it. So now look at this. This is the data. This is just your data frame. Now look at this and how in one line you create this beautiful bar chart comparing the year 31, 32. You see that to the chart, you give it the data, you ask it to draw bars, encode it by saying column year. But because in the data there are 2 years, it will automatically draw 2 columns, 2 different charts. X is yield. You see the X is yield in the data. The barley, you're looking at how much crop harvest was there. And Y is the variety of that yield. What particular variety of barley was produced and how much was it produced? And color is the site. Where was it produced? So if you think about it, this is very, very rich visualization. There are 4 dimensions to the data. The year is one dimension, site, where you're looking at the harvest, the variety of the barley, and then finally the measure is the quantity, right, is the yield. By the way, you can interchange X and Y. I invite you to do that and see it. But I hope you see how you can use structured libraries like Altair and do very powerful data visualizations. And what is not apparent to you is that you see that these are interactive visualizations. Here, I didn't add a tooltip, but actually you can. And here, you can export it as SVG, PNG, and compile it to Vega. You can actually look at the Vega compiled code. You can even open it in Vega editor. And look at this. One line of Python code wrote a ton of JavaScript and data for you, JavaScript for you. So this is it. It's very good. Vega is a great library, by the way. Use it, and based on that is Altair. The second is, this is a famous dataset, cars. Anybody remembers the cars dataset, the auto dataset from our ML100, mileage?
Yes.
That's it. So horsepower versus miles per gallon. The more the horsepower in your car, the miles per gallon goes down. Yeah, and unfortunately, I can speak from better experience. My car has 600 horsepower, and it barely gives 13 miles a gallon. So there we go. So once again, anyway, the point is that you can see that this is created with just a couple of lines of code. Once you become familiar with this code, you realize it's very powerful. And but you notice that these are interactive libraries. I'm switching between colors. I am, these are not just images. These are interactive visualizations. That's the power of Vegas. This is a positive and negative graph chart with negative thing in it, right? And again, you can export it to PNG, so on and so forth. View compile Vega code. So I'll stop with that, guys. This is a tour of, I hope, the things that we will do in the coming months. We today got started with the lab with the purpose of getting a hands-on experience. The nature of diving in at the deep end is that, of course, we don't know the theory. We are going to learn the theory next time. So from next week, we'll start slowly. We'll go back to the foundations, ask what is a neural net, and we'll carefully and slowly build up the theory. But while we are carefully and slowly build up the theory, on a different track, we will actually move ahead and keep developing our expertise with the state-of-the-art models. So for example, next week lab will not only do the basics, we will also do a little bit of the automated machine learning and so on and so forth. So guys, today's lab should have been intimidating for you, for those of you who have entered it. The purpose was that I wanted to give you a flavor of what can be done. Assume that you won't understand all of this, but just seeing the code, just being able to play with it, it gives you a chance to become familiar with it, maybe borrow it for some job, for something that you're doing in your workplace. Make something out of it if you can, but don't get intimidated. We will cover all of these things very, very slowly. The next session, next week, will start from the very, very basics. It starts from what is a perceptron, what is a neuron, and what is a neural network. We'll start from there. Are we together? So the lab, the homeworks, guys, please do the homework. I'm going to release another quiz tomorrow evening. I'll try to do it on Saturday. We'll discuss the solutions to both homework, week 0 quiz and the week 1 quiz. And the week 1 quiz will be on all these things, these buzzwords that we talked about, transfer learning and automated machine learning and explainable AI and so forth. Kate, go ahead.
Yeah, I noticed it's probably need the homework all listed in one spot. I guess we'll use the chat. I'm still more used to Slack channels for that, but also referring to the notebooks, with the directory structure based from the root where everyone's going to have it, the deep learning, the name of the notebook, and to say to look in that notebook at the bottom where there'll be homework stuff to look at. There's one place that kind of lists there's stuff in the bottoms of these various notebooks in these locations to look for homework assignments.
Exactly.
Because they're written up nicely, but they're in the very bottom of various notebooks.
Yeah, my hope is that to find the homeworks, you'll have to read the notebooks.
Right, but telling people the order which ones to look at.
Oh yes, yes. If you can that will be wonderful. Let's post it onto our. Well, I'm using the word Slack, but let's post it on our discussion group in our social forum.
Okay, I'll take some time to do that tomorrow.
So guys, now I'm going to stop the recording and I'll open it up to question. You guys have all been unusually quiet.